I firstly complete the patient's file card with the name of the dentist, patient, and technician, as well as the scan date. I confirm with OK. I can now specify the restoration in administration. We want to create a multi-layer crown. For this, I go to Individual Tooth Restoration, Crown, Biogeneric. That is the design mode, and several layers to work in the multi-layer mode. Click on Tooth 16. Select the milling unit. The veneering material, Emax CAD, and the framework material, and confirm with OK. In the second step, I switch to scanning. I then have 3 scans: the buccal scan for registration of the preparation and the opposing jaw, the upper jaw as the preparation, and the lower jaw as the opposing jaw. Model calculation is next. After model calculation, I assign the buccal scan. If it is rotated through 180 degrees, I click on the lower half, which serves to automatically rotate it in the direction of the preparation where it is automatically taken into account. The same drag and drop procedure applies for the lower jaw, and the software processes the information automatically. I can now check my contacts in the occlusion via Analysis Tools. Model contacts in order to compare these with the articulator if necessary. I then align the model axes toward mesial and distal for all 3 axes. I confirm with OK and am taken to the model mode where I can hide the adjacent teeth. If the wrong area is hidden, do a double-click, and this is then shown. Double-click to start, click once to fix, double-click to end. Draw the preparation margin. Double-click to start the automatic preparation margin finder. If the preparation margin is not clearly visible, I also have the option of drawing manually with the spacebar or switching to the intensity image with a further click of the spacebar. This is done via the spacebar or on the right-hand side via the preparation margin mode. I also have the option of changing this at a later date. Double-click to start, one click to fix, double-click to end. Once the preparation line has been drawn, I change to the insertion axis. Here, the undercuts are shown, and using the crosshairs, I can now change the insertion axis. I confirm with OK and am taken to the parameter mode. The anatomy is determined here. At present, biogeneric is set. If a different basic form is desired, this can be set here. Spacer for the fit of the restoration between the zirconium oxide and the veneer ceramic. The minimum radial and occlusal wall thickness corresponds to the material manufacturer's recommendations. Milling radius correction for direct fitting and blocking out of undercuts. I then see the parameters for my bottom layer, i.e., the framework. Spacer vis-à-vis the preparation, minimum radial and occlusal wall thickness, margin reinforcement, telescope angle, and the milling radius correction including undercuts. I confirm with OK, and am presented with a first biogeneric proposal. I can then design my crown anatomically, and I activate my tool wheel. Here, I have the option of changing the anatomy again via biogeneric variation. I can move the controller to achieve the desired anatomy. Right-click, Shape Tool, Circular. I can now position my buccal cusps. For this, I show the lower jaw and move the cusps. The emergence profile to apply a little pressure to the gingiva. The same is done lingually. I deactivate the opposing jaw and check my contact occlusally. I now also have the chance to move my fissure slightly. An extremely strong contact. Let's reduce this somewhat. If desired, now build up the central contacts. I check my proximal contacts via model trimming. I can create even stronger contacts here. Reduce slightly. Red indicates a very strong contact. The same is done mesially. Once I have achieved the desired anatomy, I can divide the restoration. For this, I do a right-click on Divide, Apply, and the software then divides the restoration into a framework ceramic and a veneer ceramic. I can select both restorations. For this, I click on the lower edge and am currently in the framework ceramic, or here in the veneer ceramic. In both cases, I can see that the minimum wall thickness has been slightly undercut. To remedy this and achieve the desired material thickness, I can use the Shape tool. I do this in a circular motion. I prefer to build up more material, as I can also polish this down again later if necessary. I then return to my framework ceramic and can also build up some cusp support if necessary. I now jump to the milling mode where I can change the sprue location. If necessary, proximally, in order to avoid aesthetic flaws. I could now produce the framework ceramic via milling. During sintering, I have the opportunity to mill my veneer ceramic in lithium disilicate. The same applies here. Position the sprue location if required. In this case, I would not place it on the proximal surface in order to retain my contacts. I then activate milling.